Parentheses are always a way you can eliminate any ambiguity from a problem. This right up here could be interpreted either way, and depending on how you enter the numbers, you'll get whichever result it is. Now let me show you how you can use parentheses. I can take 1 plus, and now this is a parentheses sign, so I hit the parenthesis, and notice it says 0 up here now because it's wanting me to enter what's going to go between the parentheses. So I'm going to hit 2 times 3, and then I'm going to hit the right parentheses. And that gives me 6, but remember I'd already added 1, so when I hit the equal sign, I now get 7. Now if that wasn't clear, you need to take a calculator and go back and do this yourself and make sure you understand it. In fact, I didn't say this in the beginning, and I should have. You really need to have the calculator you're going to use when you go through this video to be sure that you understand how yours works. Indeed, if you're going to use the 30XA, then you need to have that, and you should pause the video and kind of do everything I'm doing to be sure you fully understand it. Now, let's see. That's how these keys here work. And you can do very complicated problems by using parentheses. Let's take 1 plus 2 divided by 4 times 7. That, of course, we can do in our heads. That's 3/11ths. But let's kind of do that together. Let me see if I can get this centered where we can see that okay. Okay, what I'm going to do is I'm going to take 1 plus 2. I didn't use parentheses yet, and I got 3. That's my numerator. Now I'm going to divide. Now if I just put in 4 plus 7 equals, I don't get the right answer at all. So what I've got to do now is 1 plus 2. I cleared the calculator. I get 3. Divide. And then I'm going to hit parentheses. 4 plus 7 parentheses. That's 11 now. And then when I hit equal, I get 0.27, which of course is the correct answer, 3/11ths. So never hesitate to use parentheses if you aren't sure about how the calculation might turn out. I use them all the time because I can never quite remember sometimes how this is going to work. Now, another thing I want to show you that can be handy sometimes is the memory registers. There are actually, STO means store in memory, and RCL means recall from memory. There are actually 3 memory registers with this particular calculator. Now, some calculators don't have any memory at all. Some have 1 register. Some have multiple registers. This has 3 registers. And here's how this works. Let's say we're doing a calculation. 3 times 5 equals 15. And we want to save that for a future use. So I can come up here, and I can hit store and hit 1. And now that is stored in the first memory, memory 1. Now let's say I'm doing another problem. I do 8 times, and I want to multiply it times that number I stored. So remember I hit 8 and I hit times. Now I do recall 1, and there's 15. Then I hit equal, and there's the product. Now that 15 is there, and it'll be there until I change it, or until I wipe it out. Even if I turn off the calculator, if I turn it back on and hit recall 1, 15 is still there. That's a remarkable thing about electronics today. Even though your calculator is turned off, the memory in these memory registers doesn't go away. Now let's take 6 times 8 equals 48, and let's store that in the second register. Now let's recall the first register, that's 15. Let's add that. Let's recall the second register, 48. Let's hit equal, and there's the sum of those two. Now this is handy if you're doing complex calculations and you need to save a number for later use. In fact, in one of the examples I gave where we were trying to evaluate e to the minus pi over 2, you may recall, if you've ever seen that particular video, that's a very interesting and famous, interesting number that most people have never heard of. It turns out, as you may recall, if you study that video, it's the square root of minus 1 raised to the square root of minus 1 power. And by the way, nowhere on your calculator will you have the square root of minus 1. That's what's called a complex number, and this calculator only deals with real numbers. However, it turns out that when you take square root of minus 1 and raise it to that power, it gives you a real number, e to the minus pi over 2. Now, pi is a number that's on your calculator. That's the number that is the ratio, the circumference to the diameter of a circle. And I'm going to go ahead and fix this to a couple decimal, let's say 4 decimal places. 3.1416. And I want to take divide it by 2, and then I want to make it negative, and now that's minus pi over 2, and so I'm going to store that in the second memory register. Now E, and I won't tell you what that is. We have a video where we explain that, but the way I get to that is I just take 1 second ln, and there's E. I put that in the y to the x key. I recall minus pi over 2 into equal, and 0.2079 is the answer. Now, I didn't expect you to follow just all that I said then, because I have other videos where I explain that in detail. In other words, why would this equal that? That's in this video on complex numbers that in the serious student section. But I just show you how you can use the memory register. Now, there are some special keys that you use occasionally that are nice to have. There's a square root key, so if I take 25, and then if I hit the square root key, that'll give me 5, which of course we know is the answer. But now I can take any number. 6, 8, 9, 7, 4, take the square root, and there's the square root. 830.5. I'll fix that to 1 decimal place. Then there's the square key. If I square it, I get the number back. So if I take 5 and hit square, I get 25. If I take 7 and hit x squared, I get 49. Then there's the 1 over x key. If I hit 1 over x, now I've gotten rid of the digits there. So now by fixing it at 3, 0.02. So for example, if I take 5 and hit 1 over x, I get 0.2. If I take 2 and hit 1 over x, I get 0.5. I hit 1 over x again, I get back to 2. 1 over x is one of those functions that if you do it twice, you get back what you started with. Start with 5, 7, 8, hit it once, hit it twice, you're back to 5, 7, 8. This, as I told you, is the pi key. Now we have a whole video on the y to the x key, so I won't belabor that right now. I'll just point out that if you take 3, put in y to the x, put in 4, you're going to take 3 to the 4th power, or 3 times itself 4 times, and you'll get 81. And that's a very valuable key, very important key that can be used for certain types of problems. Well, that's an overview of the calculator. That's all I'm going to do now. I encourage you to play with it and learn about it. And I might point out that it will come with a manual, and also it comes with a quick, with a very quick cheat sheet on the back here. This white thing here has all the different functions described, and so you can always go back there. In fact, I'll tell you a little story on myself. When I first bought this calculator, I really liked it, but I didn't know it very well yet, and I wanted to save a number. So I hit a number, say 5, and I hit store, and then I went off and did something else, and I came back and hit recall, and nothing happened. I didn't get my 5 back. And I actually thought the calculator was broken because I didn't know that it actually has 3 storage memories, and you have to hit store and hit a register number. And it wasn't until I finally read the instructions that I finally understood that. And so you can play with this calculator, read the instructions. I've showed you the basic things here that we're going to be using over and over. I think you'll enjoy it. And so this is Dr. Dell signing off. I hope to see you a lot of other of our videos. Have a great day. Bye-bye.